Every day, seafood processing plants around the world discard thousands of tons of fish skin as waste, peeled away, thrown out, and forgotten. But inside this facility, that waste never reaches a landfill. Instead, it begins a journey most people will never see, a transformation from slippery, discarded fish skin into something unexpected, soft, durable, genuine leather. This is fish skin, from waste to wardrobe. Welcome to a modern fish skin tannery, where salmon and tilapia byproducts arrive daily from seafood processors with one purpose: to be reborn as leather. Fish leather isn't new. It's one of the oldest materials known to humans. But today's process is faster, cleaner, and more precise than ever, using a mix of traditional tanning chemistry and modern automation. Over the next 20 minutes, we'll follow fish skin through every stage of that transformation, from raw, discarded offcuts to finished leather, ready for shoes, wallets, and fashion goods. Let's step inside. The process begins before the skins even arrive here. At nearby seafood processing plants, filleting machines separate flesh from skin in seconds. And what's left over, skin still damp, faintly iridescent, streaked with scale patterns, is packed into crates and refrigerated for transport. At the tannery, refrigerated trucks back up to the receiving dock, and workers begin unloading crates stacked with salmon, tilapia, and perch skins. Each crate is weighed and logged. A single delivery can bring in over 2 tons of raw skin in one trip. From here, the skins move onto an inspection conveyor. Workers in gloves and aprons sort by species and size, since different fish skins vary in thickness, flexibility, and grain pattern. Salmon skin, prized for its diamond-shaped scale texture, is sorted separately from the finer-grained tilapia. Torn, undersized, or damaged skins are pulled aside for a lower grade of processing, while intact skins move forward toward the next stage. A quick rinse under cold water removes loose debris and surface slime before the batch is loaded into holding bins. At this point, the material still looks and smells exactly like what it is: fish. That's about to change. The sorted skins move into the descaling drum, a large rotating cylinder lined with textured paddles. As the drum turns, the skins tumble against the paddles and each other, and the friction lifts away loose scales, leaving the surface smoother and more uniform. Water constantly flushes through the drum during this stage, carrying away loosened scales and debris through a mesh filter at the base. The runoff is collected separately. Even fish scales have value. They're often reclaimed for use in cosmetics and calcium supplements. Once descaled, the skins are transferred to a soaking tank filled with a mild alkaline solution. This bath softens the tissue, relaxes the collagen fibers, and begins loosening any remaining flesh or fat still clinging to the underside of the skin. The skins soak here for several hours, fully submerged, gently agitated by paddle wheels to keep the solution circulating evenly. When the skins come out of the soak, they're noticeably paler and more pliable than when they went in, the first visible sign of the transformation to come. Next, each skin passes under a fleshing machine, a rotating blade cylinder that scrapes the underside clean, removing every trace of residual fat and muscle tissue. What remains is a thin, translucent membrane of pure skin, the raw material leather is actually made from. This is where fish skin truly begins its transformation into leather. The clean skins are loaded into large, rotating tanning drums, stainless steel cylinders several meters wide, each capable of holding hundreds of skins at once. Inside, a tanning solution, most commonly a chromium-based, or in eco-focused facilities, a vegetable tannin-based liquid, is added, and the drum begins to slowly rotate. Tanning is the chemical step that keeps skin from decomposing. Untreated skin, left alone, would break down within days. But as the tanning agents penetrate the collagen fibers inside the skin, they bind to the protein structure and stabilize it permanently, turning perishable tissue into a material that can last for decades. The drums rotate continuously for several hours, tumbling the skins through the solution so every fiber is evenly treated. Sensors monitor the drum's internal chemistry, checking pH and temperature to keep the reaction consistent across every batch. Midway through the cycle, technicians pull sample skins and perform a boil test, dropping a small cut piece into boiling water to see if it holds its shape. A properly tanned skin resists boiling without shrinking or curling. An under-tanned one won't. This simple test tells the whole facility whether the batch is ready to continue. Once tanning is complete, the drums drain, and the skins are rinsed thoroughly to remove any excess tanning solution. At this stage, something remarkable has already happened. The skins that went in, fragile and perishable, now come out structurally stable. Genuine leather in its rawest form, sometimes called wet blue, for the pale blue tint chromium tanning leaves behind. The skins are then lightly wrung and stacked, ready for the next transformation, turning stable but rough tanned skin into something soft, smooth, and usable. The wet, tanned skins move into a second set of drums for retanning, a stage that fine-tunes the leather's final texture, feel, and color. Here, the process becomes almost artistic. Dye is introduced directly into the rotating drum, along with fat liquoring agents, oils that penetrate the fibers and give the finished leather its characteristic softness and flexibility. As the drum turns, the skins darken in real time, shifting from pale wet blue to deep, rich tones, black, brown, burgundy, or a natural translucent finish that shows off the scale pattern underneath. This is the visual heart of the entire process. The moment a rough, chemically stabilized skin becomes something that unmistakably looks like leather. The scale pattern, once just fish anatomy, now reads as a striking natural texture, almost like a fine, dense grain. Different batches are dyed for different end uses. Matte black for wallets and belts, natural translucent tones for high-fashion accessories, deep browns for footwear. Each color run is a separate cycle, carefully timed so the dye penetrates evenly without leaving light or dark patches. When the drum finally stops and drains, workers lift out skins that bear almost no resemblance to where they started. What began as slippery fish waste has become soft, pliable, richly colored leather, durable, flexible, and ready for finishing. Before the leather can be called finished, it passes through a careful refinement stage. First, each skin is stretched onto a frame and left to dry evenly under controlled temperature and humidity. Drying too fast causes stiffness and cracking. Drying too slow risks mold. Facilities like this rely on climate-controlled drying rooms to keep every batch consistent, with airflow and humidity levels checked continuously. Once dry, the skins move to inspection tables under bright, even lighting. Technicians examine each piece for consistency of color, flexibility, and surface texture, checking for any weak spots, thin patches, or uneven dye absorption. Skins are graded, Grade A, for flawless pieces, destined for premium fashion goods. Lower grades, for uses where minor imperfections won't matter, like linings or smaller accessories. A tensile test is performed on sample pieces from each batch. A machine clamps both ends of a small offcut and pulls until it stretches, measuring exactly how much force the leather can withstand before tearing. Fish leather, despite coming from a much thinner starting material than cowhide, is famous in the leather industry for being remarkably strong for its weight, often stronger, gram for gram, than traditional leathers. Skins that pass inspection move forward. Any that don't are set aside for recycling into smaller leather goods or scrap-based products, ensuring almost nothing from the original raw material goes to waste twice over. The graded skins now move to the finishing line, where they receive their final treatments before becoming usable material. A buffing machine gently smooths the underside, the flesh side, of each skin, giving it a suede-like softness for lining use. On the scale side, a light protective coating is applied, sealing the surface and enhancing the natural sheen of the scale pattern without hiding it. Some skins pass through an embossing press, which lightly flattens and evens out the scale texture for a more uniform commercial look. Others are left raw and irregular, prized specifically for their natural, unrepeatable pattern. No two fish skins are ever perfectly identical, which is part of the material's appeal to designers. A final measuring station scans each finished skin, calculating exact surface area in square inches. Because fish skins are naturally small and irregularly shaped compared to cowhide, Precise measurement matters enormously to the fashion houses and workshops that will eventually cut patterns from them. Each finished skin is then trimmed along the edges to remove any thin or damaged tissue, leaving a clean, usable panel of leather, supple, textured, and strikingly different from the discarded fish skin it once was. In the final stage, the finished leather panels move to the packaging area. Each skin is inspected one last time, then carefully laid flat and interleaved with protective tissue paper to prevent creasing during transport. Batches are sorted by color, grade, and size before being bundled into flat packs. A labeling machine attaches a tag to each bundle noting species, grade, dye lot, and total surface area. Critical information for the tanneries, fashion houses, and workshops that will purchase them. Some bundles are destined for luxury accessory brands, others for footwear manufacturers, still others for smaller artisan leatherworkers ordering in bulk. The packed bundles are boxed, sealed, and loaded onto pallets, ready for shipment around the world. A striking contrast to how this material began its journey, as fish skin, discarded in bins at a seafood processing plant just days earlier. From slippery, discarded offcuts to soft, richly colored leather strong enough to rival traditional hides, this entire transformation happens in less than a week. Every year, facilities like this one turn thousands of tons of seafood industry waste into a genuine, durable material, reducing landfill waste while producing a leather that's lighter, often stronger per gram, and completely unique in texture. What was once thrown away is now stitched into wallets, shoes, and handbags around the world. And it all starts with something most people would never think twice about throwing in the trash.